So sorry for this late. There's some issues with the, I don't know which what. I mean, because I'm using this Mac in all the events and always work, but yeah, probably I update it or who knows. I will check it out later. But that's the bad news, yeah. And I've got all the demos in that laptop, which it means that we are not going to see all the things that I'm going to show you in action. But there is always the link on the GitHub repo. It's super easy to run them. And even in some of them, there is a link to a YouTube video, so you can see it later. Okay, so let me start. My name is Alex Soto. My tutor is Alex Soto B. My email is sotoboy@redhat.com. I work in Red Hat. I am the co-author of all these books. In this QR code, if you go there and you register, you can download it for free, the 3 last books. The GitHub Cookbook, the Ansible book, and the Applied AI for Enterprise Java Development. You can download it for free. They are from O'Reilly. And some of the topics that we're going to cover today is in the last book. Okay, so again, there you've got like a step-by-step instructions for running the demos. Okay, so, well, this is not applicable now because you know that LLMs are unpredictable, and I will say that, hey, just keep in mind that my demos might not work, right? Because sometimes, you know, models give you the wrong answer. But today there's not going to be a demo, so no worries. The second thing is that I'm a Java developer. I'm not a data scientist, okay? So for me, all these LLMs, models, and so on is like this black box, okay? It's something that I just sent a request and I got a response, okay? I know that it's not entirely true because, yeah, I've been digging out a bit inside this black box, but after all, it's all, you know, all are a lot of math and so on. So most of AI nowadays is Python, right? And I do not have anything against Python. Just, yeah, it's fine for pet projects. But when you're going to real-world projects, yeah, probably you need something else, something more powerful, right? Also, yeah, you know, Java is better for the planet than Python. You see that it's like around 40 times better, consuming less energy than Python. Or also, I don't know if you've been working with Python, but I've been doing it, a bit of things, and every time is a headache. Every time, you know, you updated one library, and everything blows up. You say, oh, yes, I'm going to upgrade from version 3 to version 3.1. Oh, things stops working. Why? Well, because it's Python after all, right? And one of the main reasons I would say that I will just go to Java is because big corporates uses Java, right? When you want to deploy, you know, enterprise applications, you're going to go with Java. Of course, any other languages, but you want support, you want a stable platform, and then Java is a really good option. And to getting started with Java and AI, there is the LangChain4j. Probably some of you already know this project. There are others, like, for example, Spring AI as well. But LangChain4j is a Java project that lets you connect to LLMs to models. And I like to say that LangChain4j is like a REST client with asteroids, okay? Because it's a REST client, right? That sends a REST call to a model, and then it gets the response. But it offers all these extra features. For example, it lets you create prompts. So prompts basically is the text that you're going to send to the model. But thanks to LangChain4j, you can create templates. So you create your prompt with some templates. Like, for example, what is the capital of? And then you put there a placeholder. And the user is the one who fills this placeholder. So you see that LangChain4j offers this prompting with templates. Also, it offers you the memory concept. You know that models by default are stateless. So you can ask something, you get the response, and you cannot refer to the previous question. It's always, you send a question, you get the answer. With LangChain4j, it implements the memory concept, which is like, let's say, simulate that the models are stateful. Okay, so thanks to LangChain4j, you can consider that your model it has memory. Of course, inside it uses, a concept of appending the requests and responses to the original request all the time, right? So it's just providing the context to the model. But you can think that it's like a memory. Also, it's like an abstraction layer for LLMs. So you add a dependency, and you've got a connection to OpenAI. But if you change the dependency, and you, for example, add the Google AI dependency, then you've got, or Gemini AI, then you've got the connection to Gemini. Just changing the dependency. It also lets you develop agents, and of course also provides you all the, let's say, the pieces to make RAG applications easy to develop and understand. And that's great, right? Just as a reminder, if you want to use LangChain4j for instantiating the connection to the model, just put, okay, I want to use OpenAI, I put here the API key, the model name, build, done. You've got this chat language model. Actually, this has changed. In the latest version, they changed chat language model to chat model, but it's exactly just a different name of the interface, but it's an interface. And then, yeah, you can start creating the concept of AI service. You see here, I'm just creating an interface which is named Trivia, and I'm putting here, you see two prompts. One is the system message, which is the system prompting, where you say, return the capital of given country, respond only the city. And then I've got the user message, which is the user, or the message that the user will provide. And in fact, I'm just putting what is the capital of, and then I'm putting here the placeholder. And you see that in the method, in this interface, I'm going to say, hey, the user is going to provide you the country, and just replace, right, the placeholder. Then I do AI services.create, I put here the interface, I put the model, and done. I've got, with this, an interface. In fact, inside it's all the implementation, all the logic to connect to OpenAI, and then I can do trivia.question Japan, and it will return me Tokyo. Okay, super easy. Again, if you want to have memory, you only need to provide this chat memory. You put, okay, I want to have a memory of 10 messages, and done. Then, at this point, your model is not stateless anymore. Well, the model is still stateless, okay, but yeah, you get the point. And yeah, also it provides this, what's known as function calling, right? Which is like, okay, I just create a method, a Java method, and then in my, when I need to call that my model, I also send to the model, hey model, if you need to send, for example, an email, right, call this method. And then, if the model needs to send an email, it will get back to my application and say, hey, can you invoke this method? Then you will invoke this method, and then the result will get back to the model. Okay? Probably nothing new. I mean, I know that it's just a quick recap of what you can do nowadays with LLMs. So you can create chatbots, or RAG applications, or vector embeddings, or even sentiment analysis, right? Send an email, and you said, okay, this mail is a positive email, negative email, neutral, aggressive, and so on, okay? That's fair. And here will come the first demo, okay, which is basically, I just clone mobile application of PortAventura, which was super cool because I was there and I saw that they had a chatbot. And you can ask questions like, what is the waiting time of this ride? Or what are the rides near me? Or can I go to this ride if my height is, I don't know, 150 centimeters and things like that, okay? And it responds yes, no, and so on. So I did this demo, and basically what I wanted you to see there, that there is a really big problem. It's like, I am a human, I'm in the chatbot, and I'm connected to LangChain4j asking a question. For example, what is the waiting time for this specific ride? The problem that you get with this is that in this request, you're putting three things. First of all, you're putting all the information of the rides. Is this information useful for this specific question? The answer is no. But LangChain for J doesn't know it. You just configure it that it can use RAG, it can just embed documents. Also add the waiting times for the writes, which is useful. And also, in this case of this application, also is appending the GPS position of the mobile phone. Because if I'm asking, what are the writes near me, I want that the chatbot responds me with the writes near me. So I'm just putting all this information in the request that I'm going to send to the LLM. And of course, you might say, it's not required all this information, right? Because I only ask about the waiting times. Yes, I know. But when you're creating an agent and you're configuring the agent, you're putting all this information. So after all, what you get is you're sending to the model the system prompt, the user prompt, possible useful text segments, because at this point, you need to send the documents that might be needed for the LLM to create the response, and also the tools information. Remember this example of, I want to send an email. You need to send to the model. If you need to send an email, call this method, right? So all this information goes to the model. Even though maybe it's not necessary, but it goes to the model. Which means you're sending more tokens than the ones that are required. The answer is slower, because you're providing more context to the model. Also, of course, the cost is increased. You get hallucinations. The more information you provide to the model, the biggest change to get hallucinations. Maybe unwanted behavior. Maybe just start calling a tool when it should not call that tool, but you're providing this information, so maybe it's going to try it. And also makes your model harder to test. And of course, you might say, oh, easy. I'm just going to create multiple connections to the model. So I'm just going to create something like this, right? I've got one model that is going to be called when I have information about RAG, another model, which I'm going to call it with the information about waiting times, and another with the GPS connection. And that's great. Now I'm not sending all the information to the model. I'm just sending the required information to each of the model. But there is a problem. I need another model to decide which is the configuration that I require in this time. If I want to get the waiting times, okay, I need to validate the request of the user and say, oh, it's asking me about sending, or it's asking me about waiting time, so I'm just going to send this request to this model. Oh, it's asking me about, where is the rights around me? So then I'm going to call the GPS model. That's great. And you end up with something like this. With a switch, it says, okay, route LLM, what is the next prompt? And then this LLM will say, it's the weather, it's the waiting times, whatever. Yes, works. The problem is what happened in this case is a simple example when it's growing the complexity. When you do not have like 3 models, but you've got several models. Or when you've got multiple possible options. So maybe it's like, oh, you can use model 1 and then model 2. Maybe depending on the request, you need to call two models. Then what you're going to do. Or what happens if you want to have a human interaction? Something like, hey, I just ask a question. The model tries to answer this question and says, is this correct? And then maybe you as a human say, no, this is not correct. Change this for that, right? You see that there is some kind of human interaction there. Or if you're trying to categorize emails, maybe the model has no way to categorize correctly the mail and say, hey, I don't know how to categorize this email. Can you do it for me? You see that there is some kind of human interaction. And this makes more painful if you just put code there. And of course, more things like parallel runnings. What happens if I want to run in parallel some calls to these models? Or if I want to have persistence, I want to store the workflow of the request. And this is exactly what LangGraph for J is about. Okay, it's like just putting, creating graphs of execution. Basically, it lets you create complex scenario with multiple paths as any other graph. Also, this graph It's stateful. It means that you can send a request to this graph, stop it in any place, and resume it later. Or, if you want, it can end the graph execution, and at the end, you can validate that it has executed all the steps. Or, if there is a user that complains about the answer that you sent to him, you can say, oh, wait, let's see what was the graph execution. So it stores all this information. Also, it lets you create this human interaction. You can provide some notes saying, here in this place, I want you to stop the execution and wait for the input of the user. It allows you also parallel executions, also let you define subgraphs. So what's happened when you have a big graphs, especially when you're, it's not the topic of this session, but when you're starting using advanced RAG techniques, you end up having subgraphs. Okay, that's super powerful as well, and also supports the streaming model. So let me just introduce you some graph concepts. This is the start and end node. It's always these start and end nodes, and you need to define them. Then there are nodes. Nodes are just, or the main purpose of a node is execute a function, Java code. Here in this Java code, it can be a lang chain for J code, or it could be anything, any code. The good thing is that LangGraph for J integrates really well with lang chain for J, which means that it's easy to put lang chain for J logic into a LangGraph for J node. Okay? And at the end, this node also changes the state of the graph. You will see in a moment what is the state. Then we've got the edges. The edges are the connection between nodes, which defines the flows, how the request navigate through the graph, and an edge can be conditional or not. You see here a conditional graph, which is like, okay, if the input of the user is greater than 18, then go to this node. If not, go to the green node. And then there is the state. And the state is where you store all the information of the graph. And you can think that it's like a key value map, okay? Then internally, this can be mapped or back as a memory instance or as a database or like a Redis or something like that. That's another topic, but the state of the graph is a map of key values. And for example, at the beginning, the user sets the prompt. And then, step by step, the model, each node is adding or modifying these key values. So, for example, this is a demo that we will see. This is a really simple graph where you say, okay, I've got a node with two uppercase logic. You see that there is no line chain for J, nothing logic, it's just a uppercase. And then there is a conditional edge. It says if the value of I is divisible by 2, then goes to node number 2. If not, goes to node number 3. And basically it says if you go to node number 2, surround the query with this, the star icon. If not, it's with the plus icon. Okay. So I've got here the query. This conf is awesome. This is the message that the user entered. Then I've got the I equal 2. Entered by the user as well. And then at this point, when you end up the execution of this node, you've got this conf is awesome in uppercase. Then, since it goes to node number 2, and it just surround this message with the star icon. That's how it works. Easy, no AI, I know, but it's code. And then it ends up the graph execution. Of course, you can even do it more complicated and say, hey, I want to create a stop. So instead of finishing the graph, what I want to do is wait for a manual step, saying, well, this is the output, that's fine. But what about if the user might say, I want to change this. You see, now it's this conf is awesome is in uppercase, then it's this conf is awesome with the star, and at this time, the execution of the graph stops here. You see that the graph has not reached the end node yet. So it's here, waiting for the human input. Then, of course, the human input comes. Then there is this graph saver, which basically is where you store this state. And then maybe the user says, hey, I want to change. And instead of the star icon, I want to put this minus icon. Okay? Then it changes the message, and it finishes. Okay? So you can see that this is a valid use case, especially for some demos where you want to provide feedback to the model. And LangGraph4j makes this super easy. This is this example. Again, here you can just check the code and everything. Easy to execute. Then it's like, okay, that's great. I mean, you will in this, if the demo work, you will see all the all the code, and it's like, okay, let's add the AI part. Let's add the LangChain4j part. And the example, you'll see that it's a bit more complicated. In this case, what I'm doing is, a customer service. I'm implementing a smart customer service. Basically, when you send an email, I want that this email is categorized. Okay? Then, when it's categorized, I want to provide maybe an automatic response. Maybe what it's asking me is like, okay, find the answer in internet, or maybe the model says, I don't know what to answer, so I'm just sending an email to some human reviewer to say, hey, just write the answer email. Okay? Then you can see, well, in the demo of this, what you will see is like if the user says something like, oh, I really love the staying on your camping, then automatically gets a response saying, thank you very much for coming, and I hope that you enjoyed, and so on. But there is another use case where I ask, hey, I'm just going to be in your camping in July. What is the weather there? In this case, the model will just route the question to the node of the LLM that can get the weather information, and then finally send the response. So basically, this is how it works. You've got a node which basically configures, categorizes the mail, saying, okay, this is feedback, so I can just generate an automatic response, or maybe it's a question, so I need to figure out if I need to send the request to a human, or I can just use Google to get the answer. So here you see that it says, okay, if I'm able to get a response, then try to find it, okay? Maybe using here, as you can see, Google. And then when I got, well, in this case, it's Tagly. Then when I've got the answer, for example, about the weather, then I'm just going to draft a response. So I'm just send to the model, draft a response. If the answer doesn't require Google it, then it would just create this answer and send it to draft as a response, or maybe it's going to stop, as say here, because I have no way of generating a correct response. Then let's suppose that the user is asking me about the weather, so I just go to node 1, then node 1 says, yes, if you Google it, you will find the answer. So then yes, I go to Google, node number 2, then I draft the response of the mail saying, oh, thank you very much for your interest, and things like that. Then the next thing is like, is the mail addressing the original email? Because keep in mind that maybe the model is hallucinating. So you want to avoid sending an email to a customer with some kind of hallucination. So you ask, are you addressing the original question? Maybe it's a yes, so then it sends the mail, but maybe it's a no. If it's a not, then you're using, again, a model saying, how can you analyze how to improve the email? Then maybe the model says, oh, it's true. It's asking me about the weather, and I'm sending about how to arrive to the camping. So, okay, I'm just going to find the weather. It will find the weather, and then it will improve the draft. So it's going to rewrite the mail, and then finally send the email. Okay, this is you've got this email, this example here. I mean that you do not need to any infrastructure, nothing. Well, just the OpenAI key and a Tabili key, but that's the only things. The rest, it just works. And I think that we're getting, yes, almost out of time, but well, I'm just going to skip all these things. Just if you want the slides, here are the slides, okay? For the links or for the examples. And then finally here, if you want to download it specifically, this book, just go there, register, and you can download it for free. And yes, thank you very much. Sorry for these technical issues, and thank you very much.
Gracias, Alex. Una pregunta de Iván, que está por ahí. What about Spring AI versus LangChain? What will be your choice?
Oh, LangChain for J versus Spring AI. Yeah, well, what I like about LangChain for J is that it's platform or framework agnostic. It has the integration with Spring Boot, so you can use LangChain for J with a Spring Boot with no problem. You've got the integration with, for example, GraalVM, so you can compile to native. You've got the integration with Quarkus. You can use LangChain for J with Quarkus. And after all, you can use it with any Java project, Vertex or Wildfly, Glassfish, any. Spring AI, it works in similar ways, yes, but it's only for a Spring Boot. Of course, if you say, yeah, but I'm going to develop all the time with only Spring Boot, then you can choose Spring AI or LangChain for J. But if you want to have more a generic overview of Java and AI ecosystem, then LangChain for J is a good option. But of course, both of them works really well.